Today we're going to review exponents and their rules. Let's take a look at multiplication with exponents. When I have a to the m times a to the n, I know according to my rule, if there are like bases, all I have to do are add my exponents. So I would end up with a to the m plus n. Well, if we worked an actual problem out, let's say we had a to the third times a to the seventh. Our a's are our like bases, so I would end up with a to the 3 plus 7. 3 plus 7 gives us 10, so it would simplify to a to the 10th. Now let's look at division with exponents. According to the rule, it says a to the m divided by a to the n. I would go ahead and subtract my exponents as long as we have like bases. So I would get a to the m minus n. When looking at my next one, I would have a to the 13th divided by a to the 4th. I would get a to the top exponent is 13 minus my bottom exponent, which is a 4. Well, if I were to simplify that, I would end up with a to the 9th, because 13 minus 4 gives me 9. If we had exponents that were being applied to a product means we're multiplying two separate things together. So a times b. All we would do is distribute that m as an exponent, or whatever exponent was on the outside of the parentheses. We would distribute it as an exponent. So that m would have to go to my a, and it would have to go to my b. So I would end up with a to the m, b to the m. If we were to work out an actual problem, we have x times y in parentheses all raised to the 4th power. So my 4 would have to go on my x. So I would end up with x to the 4th. And that 4 would also have to go on my y. So I would end up with y to the 4th. So I would get x to the 4th, y to the 4th. Exponents applied to a quotient. If I had a quotient a divided by b in parentheses, and I had an exponent on the outside of the parentheses, I would have to distribute that exponent into the parentheses to the top part of the fraction and the bottom part of the fraction. So I would end up with a to the m divided by b to the m. If we had a problem that said x divided by y, all in parentheses, raised to the 5th power, we would have to remember to distribute that 5 as an exponent to the top part of the fraction and the bottom part of the fraction. So we would end up with x to the 5th divided by y to the 5th. If I had exponents on the outside of parentheses and exponents on the inside of the parentheses, this is called power to a power. So we're going to have exponents that are applied to other exponents. Well, that base is an a. We only have a single base, but we have multiple exponents. Well, whenever we have a power to a power, we multiply our powers. So we would end up with our a to the m times n. Anytime you have one single base but multiple exponents, we just multiply our exponents. So if I had x to the 4th raised to the 7th power, I would get x to the 4 times 7. 4 times 7 simplifies to 28, so I would get x to the 28. Anytime we have an exponent of 0, we need to know that it's always equal to 1. So if I have a to the 0, it's going to automatically equal 1. As long as our base is not 0, this applies every single time. So if I have 5 to the 0, I would end up with a 1. If I have x to the 0, I would end up with a 1. Anytime we have exponents that are negative, we want to make sure we simplify so we have positive exponents. The rule for negative exponents is if there's an exponent that's negative, we can actually change it from where it's at. We'll do the reciprocal of it. So if I have a to the negative n, I can actually change this into a fraction and actually move it to the bottom part of the fraction. And I end up with 1 over a to the positive n. And this works every single time. So if I have x to the negative 3, I'm going to put it over 1, and I'm going to move that x to the negative 3 to the denominator, and I would end up with 1 over x to the 3rd. And now it's a positive exponent. And remember, when we move it, we cannot leave it blank in the numerator, so that's how come we put the imaginary 1 there. If I were to have x to the negative 4, I could go ahead and move this negative 4 up to the top since it's already on the bottom, and that would make it be positive. So I would have x to the positive 4.